In the digital world, by encrypting data on various endpoints, organizations can add multiple layers of security. Whether someone tries to steal the whole computer, the whole library, or access specific information on the actual computer itself, endpoint encryption is going to ensure that without the right key, they can't read or understand any of the data. This is crucial for protecting sensitive information and maintaining privacy. Imagine each piece of data in a computer is like a book in a library. Some books are standalone, while others are part of a series or a collection. You want to keep all of these books safe, so you decide to put them in various kinds of locked containers. Let's look at securing data on the following assets with encryption. There's a few different types that we're going to go over, so let's be clear on what those are. We're going to be talking about full disk encryption for full hard drives. We're going to be talking about partial encryption on hard drives utilizing partitions. We're going to be talking about files at the actual file level. How do we encrypt those? After the file level, we're going to be talking about encrypting volumes on actual hard drives. Then we're going to go into databases and understanding how we can apply encryption to databases. And then finally, records inside of databases so that in a high security database, we can actually secure not only the full database, but individual records inside of it as necessary. First off, let's look at what we call FDE, full disk encryption. FDE ensures that all data on a hard drive, including both files and the operating system, is encrypted. If someone were to physically remove and access the hard drive, they wouldn't be able to read its contents without the right decryption key. This is like putting a big lock on an entire library building so no one can access it without the key that they're supposed to have. If someone physically steals the library or your computer, they still can't read any book inside of it without the proper key. Partition encryption is a type of encryption that focuses on encrypting individual partitions or sections of the hard drive. A partition hard drive might have different sections dedicated to different purposes, and partition encryption can protect one or more of these sections while leaving others in their unencrypted state. Imagine the library is divided into different sections like fiction and nonfiction, zombies or even non-zombies, even children's books. Partition encryption is like putting a lock on an entire section. You can keep certain sections locked while allowing access to others. If someone breaks in, they might only access the children's section, but not the confidential zombie section. We don't want anyone going in there. Now let's talk about file encryption, which encrypts individual files. If you have specific files containing sensitive information, like financial documents, healthcare, or anything else so sensitive, encrypting those files ensures that even if someone gains access to your computer, they can't read the files without the proper key. As the name suggests, file encryption involves encrypting individual files. When a file is encrypted, its contents are unreadable unless decrypted. This allows users to selectively protect certain files while leaving others accessible. This is like putting a lock on a single book inside the library. Even if someone inside the library has access to a section, they can't read the locked book without the special key for it. Volume encryption, on the other hand, encrypts an entire volume or a logical data unit, which can be a section of a hard drive or an external hard drive or even a virtual drive. It's a broader approach than file encryption, but more targeted than full disk encryption, as it focuses on specific logical storage units. A volume can be thought of as a shelf or a rack in the library. Encrypting a volume means locking that entire shelf. Only those with the right key can access those books, and on that shelf, protecting a specific collection within the library. Database encryption involves encrypting the entirety of a database so that all the information stored within it is unreadable without the appropriate decryption key. It provides a layer of security for the whole collection of data inside the database. Imagine a special room in the library where you keep all of the collections of rare manuscript. This room is going to be like the database. Encrypting it means locking the whole room. This ensures that even if unauthorized users access the library, the special collection remains safe and unreadable. Record encryption refers to encrypting the individual entries within the database or the file. A record can be thought of as a single set of related data, like a row in the database table. Record encryption ensures that even if someone steals the database or tries to access it, individual records remain protected. If you think of a book as a file, then a page or a paragraph in it could be a record. Encrypting a record is like putting some text in secret code on a specific page. Even if someone opens the book, they can't understand the encrypted text without decoding it. Selecting the right cryptographic method and implementing it correctly is crucial. Each of these encryption types serves a unique purpose, allowing users and administrators to secure data at various levels, depending on the sensitivity and use case of the information.